Hello everyone, we're back with a new lesson. Chapter 1, Section 2. The objectives of this lesson are knowing the SI units and the quantities they describe. Then we'll be learning about unit conversion. We'll learn how we can convert from one prefix to another. Then we'll be distinguishing between accuracy and precision. And then finally we'll be learning about the significant figures. Now, numbers as measurements. Now in physics, unlike math, we are mostly dealing with units, okay? So a number in physics does not mean anything if it doesn't have a unit. And a description of a specific physical quantity is called a dimension. Now we have several fundamental units in physics. You have length, mass, time, temperature, amount of matter, and electric current. And the last one, luminous, intensity. And these are their units, okay? So the unit of length is meter, of course, with a small letter. Then unit of mass is kilogram. Unit of time is second with small letter. Unit of temperature is Kelvin with capital K. Then you have amount of matter, which is mole. Then you have electric current, which is ampere, capital A. Then you have luminous intensity, which is candela. You should memorize all of these fundamental quantities and their SI units. And it is important to note that other quantities are just a combination of all of these units, okay? You have several other derived quantities. You have area, for example, if your teacher asks you in exam to derive the unit of area, you'll just say area is equal to length multiplied by width, okay? And you know that length is measured in meters and also width is measured in meters. So the unit of area will be what? Will be meter squared, okay? Or square meter. Or take the equation of volume. So volume is equal to length multiplied by length, or you can say multiplied by width multiplied by height. It's the same, by the way. In here it's written length multiplied by width or multiplied by height. So if you derive the unit of this one, you'll say length is measured in meters, width is measured in meters, and height is also measured in meters. If you multiply all of these meters, you will get meter cubed or cubic meter. You have density, okay? So density, the symbol of it is rho. Let me write this one, rho. It's not P, be careful, P is pressure. So you have density, which is equal to mass over volume. To derive the unit of this quantity, you will say mass is measured in kilogram and volume, you learned, is measured in meters cubed. Okay, now this is what? This is the unit of density. You have velocity. Velocity is equal to distance over time. Distance over time, okay? Now you learned distance is the same as length, okay? So you know the fundamental quantity of length is what? Is meters, okay? And you learned that the fundamental quantity of time is what? Is seconds, okay? So the unit of velocity will be what? Will be meters per second, okay? You have acceleration. Acceleration, the equation of it is velocity over time. Now look at this one. So if you do acceleration, let's say this one is A, stands for acceleration, is equal to velocity, V stands for velocity, divided by time. T stands for time. So if you do for this one, you'll say velocity is measured in meters per second and time is measured in seconds. Okay. Okay, now to make this one easier for yourself, you can say that there is a 1 beneath here, okay? And if you rearrange this equation, you'll say meter per second. It's okay, you can write this like this. Multiply by, take this number up, the denominator will be coming to numerator, and numerator will be coming down. So it will be 1 over second, okay? Multiply these two, okay? You'll get meter multiplied by 1, and second multiplied by second is second squared. This is the unit of acceleration. Now you have force. Force is equal to mass multiplied by, so you have force, which is denoted by the letter F. So F is equal to mass, which is m, multiplied by acceleration. So if you do for this one, you'll say mass is measured in kilogram, and acceleration is measured in what? You just found out that it's equal to meters per second squared. Okay, so if you find the unit of force, it will be equal to what? It will be equal to kilogram. So there is a multiplication here, so you'll say dot meter per second squared, and this is called, by the way, Newton. Okay, this is called Newton, or capital N. So if in the exam your teacher asks you to prove the unit of Newton or to prove the unit of force, you will be using this equation. Okay, F is equal to ma. Then you'll say mass is measured in kilogram, acceleration is measured in meters per second squared. Okay, then you'll get the final unit, which is Newton. These two are equal. So if in a multiple choice you have a question like this, what is the unit of Newton equal to? So it will say, it will give you this number and this unit and some other units. Of course, you will choose this one, kilogram dot meter per second squared. Okay, you have energy. Energy is equal to what? Energy is equal to force F times distance. Okay, now you found out that Newton is measured in what? Is measured in Newton. Okay, you found out that force is measured in Newton and distance is measured in, of course, in meters. So the final unit will be what? Multiply Newton by Newton. Multiply Newton by meter. So Newton dot meter. And this is called what, guys? This is called joule. Okay, so anywhere you see this unit, Newton per meter, it is called joule. And we will be covering this unit conversion in the next lesson. So please try to memorize all these units, okay? Then we will be learning how can we convert each of them. So you have tera. Actually, this is not correct. It's tera, like this, tera. This one is giga, okay? Which tera is equal to 10 to the power of 12. So you have T, 12. Giga is equal to 10 to the power of 9, okay? Which is capital G. You have mega, which is equal to 10 to the power of 6. You have kilo. Careful, kilo is what is in small letter. You have hecto, which is equal to 10 to the power of 2. You have deca, which is 10 to the power of 1. Deci is 10 to the power of minus 1. Centi is 10 to the power of minus 2. Milli is 10 to the power of minus 3. Micro is 10 to the power of minus 6. Nano, you see nano, you have 9. So nano is 10 to the power of minus 9. You have pico, which is 10 to the power of minus 12. And you have femto, which is 10 to the power of minus 15. Guys, some of you might not understand what are these prefixes used for. Okay, these prefixes only express powers of 10. Okay, let me give you a simple example. You have 100 years. Okay, 100 years, which is equal to what? Which is equal to 1 century. You have, let's say, 10 years, which is equal to 1 decade. Okay, you have 12, for example, which is equal to a dozen, okay? Which is equal to a dozen. These numbers are exactly like this. These are just expressing powers of 10. For example, if I tell you kilo, kilo alone does not mean anything. It only means 1,000. Okay, hecto alone doesn't mean anything. It only means 100. Okay, so you should add something to it. For example, you will say 1 kilometer, which means 1,000 meters, or 1 kilogram, which means 1,000 grams, or 1 kilosecond, which is equal to 1,000 seconds. Okay, so these prefixes only denote and only express powers of 10. In the next lesson, we will be learning how can we convert each of these. Okay, see you in the next lesson.